So my name is Hagen Woesner. I am with a company called BISDN in Berlin. We are still, I think, qualifying for something like a late startup. So far, we've been building prototypes for mostly SDN and NFV systems for larger system integrators and carriers. Very recently, we have released our first product. I'm also going to speak about that a bit later, but more from an architectural standpoint, so it will be less of an advertisement session, I hope at least. The problem that we're looking at in this session is completely different from 48 volts. It's more about, although I admired this talk already, it was a complete unknown world for me. Thank you for shedding some light on this. This is about software. This is about software for OCP switches, for networking with OCP. And it looks at it from a standpoint of what happens if I would go and buy a Whitebox switch from a company like Agema or any other of those. How far can I get with free and open source software? Where are the caveats? Where am I falling on my face? And what needs to be done in order to get a reliable software stack onto it? So, from talking to data center providers, what do we want to do? We want to integrate, first of all, top of rack switches, then also spine switches, into, well, that's at least what we hear, OpenStack. It should, at the same time, be manageable by IT administrators, which is not the same as network administrators. So data center admins typically have a different skill set. So we need to do some. We need to have some features which are not the entire zoo of a Cisco router, let's say, of functionality. It is pretty limited because we're speaking data center here. We do want to have, or some of the data center providers still want to have MLEX, so multi-chassis link aggregation, failover. Some people have bond interfaces, so they're actually connecting to two top-of-rack switches, although I believe one might actually want to kick out one of those at some given point in time, depending on the reliability that you want to have. So here we're speaking about a separation of tenant networks by means of VLANs. That is at least what was the first requirement. There are a number of non-goals, like I don't want to learn another CLI. And typically IT administrators know Linux quite well and know how to handle a Linux box. And we do not want to have a completely separate management system. And one thing is for sure, we cannot SSH into each and every switch and check if it is healthy and how it's behaving. So what we actually want for a data center is we would like to have hardware accelerated routing, tunneling, accelerated NATing, and fast packet I/O between VMs or containers or whatever you want to have. And then when you look into a standard OpenStack, that's what you get at the moment. That's when IT guys do networking. Then they're starting to stack OVS bridges 3 levels high. And then you wonder why you get 0.4 megapackets per second throughput into your virtual machine, because it's just a highly inefficient networking stack. There are alternatives to it. You may use SRLV, which requires specific NICs, which requires CPDK, etc. All of that is because the switches that are actually being used in the data center are used as dumb layer 2 forwarders. And they could do so much more. It's just that most of the time they don't do it because they're not required to do it, because all the networking is taking place in the server. Now, what we can do, and I don't think I'm telling you any news, when we have a look at the abstract pipeline of, let's say, a Broadcom switch, you do have some form of tunnel termination features, a VLAN table, a layer 2, a layer 3, Before that, maybe an MPLS table, an ACL table, some QS enforcement, some encapsulation, so that's basically the counterpart to the tunnel termination, and then you're done. So you could do a lot more than you're actually doing. Question is, how can we make that available for data center networking? And how much of that is free? Free or integratable into any other software? We start from the fact that there is typically a switching ASIC in a box. On top of that, there's a Broadcom SDK. If you happen to have a Broadcom switch, which I don't know the exact number, but it's the vast majority of all switches. There's also Marvell, there are other vendors. But that is the majority of top-of-rack switches. On top of that SDK, which you can get if you're really nice to Broadcom and sign some NDAs and so on, it's possible to get it. You have three choices. You can either do your own solution right on top of the SDK, which is what IP Fusion does, what Cumulus does, what a number of companies do. You can use OpenNSL, which is one of the abstractions on top of the Broadcom SDK, which is more native to what the ASIC can do. Oh, sorry, let's go back. OpenNSL gets you abstractions of create me a trunk on between those ports, assign an IP address to this port, etc. And then there is OpenFlow, which is the standardized abstraction of an ASIC. And on top of OpenFlow, you would have a number of other controllers. You would have Open Daylight. Originally, there was also Floodlight. I think Floodlight is sort of in decline or already declined. There's ONOS now, supported by OnLab. There's BISDN by us, which I will speak about later. So there's a choice of software. Now, assuming I have bought a switch, what options do we have? Within OCP, there was the Open Network Linux project. So as a proud OCP member, I go to opennetworklinux.org/HCL, which is Hardware Compatibility List, and I check. This is a much longer list. It's just a screenshot, which also has one picture of a Gina. And then you see capabilities. So is it ONL certified? What is ONL? ONL is a Debian-based Linux operating system that runs on the embedded system that actually controls the switching ASIC. As such, it is a fully complete Linux. And then we have the question of what of the previous APIs, or what of the previous programming interfaces is supported, and you find no. Sometimes you actually find a yes with those three asterisks, which means please contact your vendor because it's not free. So the answer for all of that on OCP's Open Network Linux is no. So you go and you actually cannot get it. You cannot download it from GitHub. You can download some pre-built binaries as part of Cord from OnLab. You get pre-built binaries from some of the vendors. So in principle, you can get it running, but it's not free. There are reasons for it. First of all, Broadcom is sort of picky on the SDK, so you cannot. The SDK itself is not open source, so you can't open source the entire operating system. However, one could actually provide more binaries that would actually make you going on at least OpenFlow. I have no good reason for why this is not the case. I also spoke to some people at ONF that were sort of surprised and said, yeah, we should do that. I think so too. It should be done. If we walk up one level and we ask ourselves now, what controllers can we put on top? Controllers means what is the choice of control plane? There we have, again, three choices. We can go with the standard, let's say, non-SDN, which is a distributed IP control plane routing. There's a ton of BGP extensions recently defined by the ITF. There's quite a number of data center providers that run BGP within the data center. And you don't need any controller for that, and you can run that on a number of Whitebox providers, software Whitebox providers. There's the other option, that is, you use SDN, you use open flow controllers, and that is ONOS that is being used for CORD, central office redesigned as a data center. There you would have a standard open flow controller with an OFDPA 3.0 southbound interface from the open flow controller. And the question is, how does that then integrate into the data center? So ONOS itself has a BGP speaker interface, which has a subset of BGP to then integrate into a legacy control plane. And pretty much the same is true for Open Daylight. I think they are most of the time interchangeable. I think Open Daylight is overall a bit more mature in the code base because they started a bit earlier, and it has a lot more southbound interfaces like netconf, like even SNMP and so on. So Open Daylight is much less open flow driven, although you now also do have netconf interfaces south of ONOS. So OpenFlow is not the only choice for either ONOS or Open Daylight. There's a third option, BISDN, which is much more lean and purely OpenFlow, and I'm coming to this in a couple of slides. No, I think next slide even. There's an intermediate way of controlling networks. That's at least how I see things connected. That is, you either use a path computation element, so that is a centralized box or a centralized function, and that goes together with MPLS or a legacy, any other legacy networking. So you do a centralized steering of the route computation, and then you use MPLS to signal the path setup in a legacy way. So you do have a range of choices from traditional IP-based networking up to or down to whatever you prefer, pure SDN control. Pure SDN control means the separation of control and data plane, and for most intents and purposes means a centralization of the control plane within a data center. That is something that many people would like to have because they would not want to configure the individual switch or router. So you actually want to have a centralized view of your network, and that's what you get from those controllers, and that's what you also get from a BGP speaker or from a PC. Let me briefly introduce what we did, because we thought there might be another way of solving the problem, and that is BISDN. BISDN, you can find it. It's an open source project on GitHub. It's a small open flow to Netlink vice versa controller translator. So it embeds. You can put it either directly on the Whitebox switch, or because it is an open flow controller, you can also pull it out into a separate server, and then it speaks OFDPA to the switches. And you can use Linux, standard Linux IP route, to configure the box. The box itself looks like a standard Linux box with a number of interfaces. So that means you can send and receive. So basically the first step is the physical switch connects to the controller. The controller creates a number of tap interfaces on the Linux system, and then you see a Linux system with 54 ports. And then you can do whatever you would like to do, like generating, generating, for instance, a VLAN bridge, attaching ports to it, attaching VLAN IDs to it, etc. Why do we do Netlink? Well, basically because we can take the entire zoo of Linux tools and put it directly on the box, or put it on the server. So we don't need to write a new BGP speaker. We don't need to write any new adaptation. People who know how to deal with Linux can configure this switch as well. What the switch does is it works on the switch abstract interface. It creates an abstraction. It has a tab manager at the Netlink, listener and speaker. We did some extra controller. So BaseBox works either directly on the switch, so you can even also install it on the switch. You can run it separately, or you use what we call core, which is creating a big switch abstraction of a domain of switches, such that it collects the number of switches, it creates the inner topology, and it only exposes the outer ports of a switch topology, such that it can be configured by the OpenFlow controller. So by that, we are then achieving what the PCE or what the BGP speaker would be achieving as well. The next question is, how can we make the network configuration persistent? Right now, what OpenFlow does is it's configuring table entries in the pipeline of a Broadcom switch for our purpose. When either of those components are being rebooted or are dropping off, these configurations are gone. State is lost. So a hard part of this is, how can we make state persistent? Sorry for this. I think what we are using for this is etcd. etcd is a KeyValueStore, which is a distributed database. It's part of where it comes with controller. No, it comes. Where does it actually come from? It came up with systemd networkd, but then with the.
Etcd coming from the CoreOS guys, so basically out of this Kubernetes scope.
From the Kubernetes, let's say, ecosystem or framework. Okay. So this is where it came from. What it does, it's a distributed database. You can store key value pairs. You have at least 3 instances, better 5 or 7, and then it's a rough consensus database. We use that in order to store the configuration of data, and in that it is not much different to what, for instance, ODL or ONOS are doing internally as well. It's just a way of using the means of what Linux has available on board, and we're using systemd networkd to read from the etcd database. So normally what you would do in order to make your network configuration persistent in a Linux, you have the /etc file system where Linux stores whatever configuration data. The outsetting of etcd was, oh, I can actually boot my container with an empty etcd, so with an empty etc file system. So I can boot a virtual machine, boot a container, and it pulls all the configuration before actually going into operation from an outside database. So this is cloud native design for containers. This is how you can store the entire configuration. We're using that for just the network configuration, but it's how you would do it when you only have Linux available. And well, this is what we have done then. This is as open source as it gets. So basically, You can get BISDN. You can also get the entire binaries from us because of some limitations of the NDAs with Broadcom. We cannot give you the entire world for free. So that is how we integrate into OpenStack. OpenStack then has Neutron, which is the networking component. We have an ML2 driver, which writes into etcd. We have what we call etcd connector, which reads from etcd, writes into systemd, networkd, and off it goes. And then there's some failover. So we have an etcd cluster. So we also have redundant controllers, etc. But that's basically networking done within Linux as far as we could push it. Conclusions. I think that was hopefully pretty fast. Open networking has come a long way. You can get most of what you need from Open Network Linux. Then you have to search around and ask friends if you can also get the final bits and pieces from your vendors, from your whatever partners. Still, there's somehow something sometimes missing. The whole controller northbound interface discussion is still open. There is now a discussion within ONF also about using netconf as north or even right north and southbound. There's the openconfig, restconf, whatever. We propose to just use Linux. And well, whoever would like to try it, we would be happy to assist. But just go and download and try it out. Okay, questions?
What is your support model on this one? Let's say customer wants to download your controller and they implement it. Are you going to support it, or they're on their own?
We license this one in between here. So this is what we would like to get some money and license contract. This is intentionally made as an open source project with essentially no support except for a mailing list, but we also get, of course, the regular open source support licenses.
Okay.
Anyone else?
Does it also run some Intel cards? Intel?
On Intel embedded systems or on Intel ASIC? Intel ASICs? No. You mean the Fulcrum ones, the S6000? What we can do is to run. It basically depends on the OpenFlow that the Intel speaks. If this is what you're referring to, the Intel OpenFlow, the open networking thing. There was a switch, I think, 3 years ago by Intel. Is that what you're referring to?
No, not directly, but I was just curious.
So there's if the switch speaks OpenFlow, there's potentially a little adaptation work to be done from OFDPA of Broadcom to whatever other version of OpenFlow. That's possible and should not be too hard. Correct me if I'm wrong, Toby. If you require us to, or if the question is, I only have this switch from vendor XYZ, then it always requires to have the SDK and to fully recreate an OpenFlow agent on it. And that would be, so the question is OpenFlow the right API? Facebook uses a different one. Facebook uses OpenNSL, which is sort of a different abstraction. I think we're having some internal discussions. Is it higher or lower? It is a different abstraction. OpenFlow lets you specify more and in a smaller, in a finer granularity, as opposed to OpenNSL, which is naturally more limited in functionality to pure data center use.
One question. In terms of tunnel encapsulation and decapsulation, A, I'm not sure what is supported by Linux, and B, what is then transported through BaseBox D to OpenFlow?
So I think in Linux you have a lot of support for VXLAN, for GRE, Geneve. None of that is unfortunately at the moment transported through to through BaseBox D. That's
Okay, so we're talking
on
about
the that is we're talking about VLAN exclusively at the moment. We're working on layer 3 at the moment, which will be end of Q3. VXLAN is the next on the roadmap for before the end of the year, but we're not yet there.